How you do? How you do? How you do? Just waiting for everything to catch up. We got audio. Let's see if we got audio.
That was success. And now, Red Sector presents the TCC design.
I think we got. We've got audio. So I'll be with you shortly. Just make sure we're streaming. We are. Welcome, welcome. Welcome. Oops, what am I doing? Welcome to Half Greek Geek. Red Sector Mega Demo. Yeah. Right, so what have we got going on? I've tried to put it out there on various groups. So I need to make a case. Don't know if you can hear me, let me just see if you can hear me. Right, so what have we got going? You can hear me, might be a bit low, the old in the background. Welcome to the B2000. That one staying as it is. I've got another board up there. It's supposed to be working order. I need to make this case for it. So let's get it down. Let's get it. So just doing a bit of brainstorming as long with the design. Let's turn it down a little bit, maybe. It's a fully working system behind me. Anyway, I've got a spare main board and I need to make a case for it. And I want to be able to add some new things to it and maybe take it apart without taking it apart. Add USB, some MIDI ports, all sorts of modern stuff, Wi-Fi, wireless. I've got various upgrades to add to that one. I've got a new Denise chip, and I've got 2 megabyte Agnes to put in it, and I've got HDMI adapter and some other stuff, and Raspberry Pi stuff and things like that to try and speed it up. Anyway, I don't want to keep taking that apart. Also, I'll probably, if I buy some PCBs, I'd have to buy more than one. So I'd have to create, say, buy 5 or something, and make 5. I'll need to test them, so I don't want to keep ripping that apart. So I've got another B2000 motherboard up there, which I want this case to fit into. So basically, this case is going to sit next to that one on the table. So that'll sit at the side of this one that I can do the work on, basically. So we've got fit ATX power supply, maybe drives. You want it to do all the usual stuff. It's got to look exactly almost the same as That one. Well, the original case. Sort of. So basically, if you look at it, you've got to say, well, that's a B2000. Now, the materials I've got is 6mm polycarbonate clear or acrylic. Somebody said we could put a wrap around it. They'd sell a wrap for the metal side of things. I'm not sure. I don't think it's for the front, but maybe you could get vinyl made to go over the clear polycarbonate at the front. Or you could buy the plastic in the right colour, maybe, and mill out the plastic. So anyway, you can add the badges. You can add the badges to it and bay covers. Anyway, so I went ahead and did a basic model of it. Using my original one for measurements, basically. Use it for measurements, and it needs to be able to be made. Needs to be able to be made out of flat. There's no moulding going on. There's no 3D printing. There's no moulding. None of that. It's designed to just made out of flat. So you've got your various covers. So everything out of flat. Flat 6mm, because 6mm is what I've got. I've got plenty of 6mm clear. Don't know if it's polycarbonate. I don't know if it's acrylic, but it's sheet clear. But that doesn't mean to say it has to stay clear. Anyway, so we need to keep the same structure. Like you see, that bit I've put there, I'm going to change that because I don't like that sticking out. So we're going to bring that in and alter that. We've got to put in the drive bays. Now I've also got a constraint. I've got my own CNC, a Chinese 6040 CNC router. Oh, that's not too loud. Let's turn it down a bit. Right, let it run in the background. I've got a lot of Amigas. Too many. Anyway, this is the one I'm gonna be sticking with. I'm gonna make some PCBs for it. Got a lot of ideas, but the one I want is to connect it up to my keyboard. Got keyboards, MIDI, and use the software I used to use years ago. Anyway, so let's. So we've got to get these port covers in the right place. Also, we've got to create a back plane for it. Now, what I've done is just put a graphic in there. Captured a graphic. It's not really any good, so I've been trying to get hold of someone else's model, but. It's not really anywhere available, so I've got to have to get the tape measure out and the ruler and build this up, and then build the connectors and model it, because we'll need to know where the cards are going to go exactly as well. So put the slots in for the cards, so it's still going to be able to take the cards. So I started this. I didn't do a live stream. I just did it enough on my own time just to create the teaser thumbnail. Wasn't going to start out that way. Anyway, so I'm constraining my CNC what size I can cut. Hence why we've got two sections here, and the base as well. So we can put all the milling for the feet and things in there. And I've created a lot of different stuff. So. Already on my channel, YouTube channel, different things. So pretty familiar on how to I know basically what works and what doesn't work. So I'll know whether it's going to work or not before I even build it, basically. So, but what I do need is an accurate model of the main board. So that's what we're going to do today. This is just an outline. But the idea, it was all made out of flat pieces. Flat pieces that screw together. Now, whether they screw directly together or with blocks, with like a square block, I've purposely made. Obviously, the metal case is only thin. This is 6mm, so I've made the inner diameter or the inner dimensions the same as what. So there's enough clearance, the same as that one. So if you put the original case and this one next to each other, this is going to be ever so slightly wider by about 10mm to compensate for the extra thickness. So in all dimensions, it's going to be slightly bigger by about 10mm, because that's the way we've got to do it to allow for the cards to sit in, motherboard to sit in, everything else. Right, so it's quite an ambitious thing to do. Anyway, so we'll set the G code. Once we created the G code, I'll give it some standard parameters. Anyway, so I should be able to go onto third-party sites, get the G code, send it over, and get stuff made. Or unless you've got a CNC cell, you could just create it yourself. But anyway, I need one. So anyway, that's the real reason for me doing it. So I did this for structure, but this angle, but I need to get that in out of the way. So we can do it. Let's do that now. Let's sort that out now. So let's get into that and just. If you don't recognise this, it's using SketchUp Make, an old version of it. So you can still get it off archive.org if you need to get hold of it. It's the one I use. I'm not into paying expensive subs for software. Right, so we've just got to clean that up a bit. We're trying to make it aesthetically pleasing as well. So that's the basic part of it. Yeah, so that's a bit better. Obviously, you've got to it's got to all be able to screw together without screws showing everywhere. Oh, what's happened here? Oh, yeah. Oh, that's already done that one for me because that's a copy of this one. So we've got some extra stuff going on here, so we need to sort that out. Right, what is that line? Let's have a look in 3D. X-ray. Oh, that's the flat of it. We'll get rid of that flat now. Oh. Hang on, I don't think that's the one. Let's have a look. Ah, it's part of that. Right, I'll tell you what we'll do. Let's come out of that. It gets confusing. So it's a long-winded thing. So I need to. It is a long-winded. It's going to be several videos or streams in the series. It's going to be several of it. So that's the inner front. Right. Okay. So you don't. Let's get rid of the sides a minute. Let's just. I did this about a week ago, so I lost track of some of it. Right, so I need to get rid of that. sort all that out. So we've got to model it like that. In reality, that can't be made like that. So that's the inner piece. So we'll sort that out after that. So that's got rid of that. Okay. So we've got a bit of a smooth thing going on. So it's got to be able to take the weight of a monitor, don't forget. And for strength, the lead has to sit on top of the sides, push down, and probably for strength, now that'll push down the, yeah, it probably needs to be underneath there as well. Right, so we'll have to probably move that. Now, the original Amiga case has got a step here on this, like similar to that, but down the side. So, if we do that, we'd have to make it out of several things. But anyway, I wanted to go as far as I could, but I can't go any further till I've got an exact model of the main board. Hence, that's why I started doing this. So, what I need to do now is just leave that alone. I don't want to do anything else to that until I've modelled the main board. So, let's do that then. So, leave that where it is. Quickly save that. Let's start by getting some dimensions off the main board. I'll just grab it down. Oh, I've got some junk on there, so let's get rid of some of that junk. Right here. Okay. Just put that down there. Right, so I've got main board here. Looks like a pizza delivery. Right, haven't had this out for a while. There it is. Just put that out of the way. So, I've got to be a bit careful, but I'm not that worried about static. Not too worried about static. So all I need to do is measure it. Need to measure it. So let's take it out. Need a bit of accurate measurement on it, so I will probably rest it on there. Oh, I've just noticed it's had the battery repair. Did I do that? Or did I just? I can't remember if I did that or I bought it like that. Anyway, it's a revision 6. Revision 6 board, and just trying to see which version it is. $89.90 it's got on the serial number. I thought it was a 6 point something actually. Yeah, it's got the I haven't even powered it up to tell you the truth. Some of the sockets are a bit rusty, so they have to be changed. It's had a little bit of work in the past on it, I can see. But anyway, the plan for today is to model it. So let's start. Let's get some basic sizes off it. So it's about 46.5 wide. Let's start off with. We'll just start off here. Let's draw a box. 460. Well, so 465 millimeters by let's just measure the other bit. This is quite a boring lot to do. Let's get the basics. It's got to be able to fit in the case. No good designing the case and it doesn't fit in. So 3, 4, 6. 3, 4, 6 deep. So 3, 4, 6 millimeters. Okay, so there's the size of our board. Well, there is a relief on it. After the ports, there's a bit of a relief on it, so let's just measure that. 150, 151. 151. So we've got to come in on it. 151. We'll get there. I'm not going to put all the connectors on today. I'm just going to all the PCB stuff. Just the connectors that stick out where the ports need to go. Right, so that depth, let's get the depth of that next. Looks like 21. No, it's 17 millimeters. So we've got to come back 17 millimeters. Okay, so we need to cut that out. Howdy. Right, so okay, so that's that. We can get rid of that from it and that one. Let's make this a component. Okay, so that's got to sit. That's the back of the board there. So I could then bring that in over it. Let's measure the depth of it. Find out what the PCB depth is. It's probably 1.6. Maybe it's thicker, don't know. It's hard to tell. Yeah, it's 1.6. So the depth is 1.6 as normal. Okay, so we could drag that over. We won't drag it into there yet, but let's have a quick look, see if it'll fit. Physically fit. Something doesn't look quite right, does it? So it's not quite right. What did I get wrong? Let's have a look. 465. Let me just make sure. My 41. What is it? 416. 416 it was supposed to be. So let's just go into it. Measure 416. Right, that's the way it's supposed to be. Let's just bring this out a minute. Made a mistake already. Okay, so we're okay now. So, why is it not playing the stuff unloading? Didn't like that. Oh, it's still going. Pause mode. Loading. Don't know. Right. Okay, so let's put this in here. Yeah, you can see you've got space. Yeah, we've got space, that's alright. So, yeah, I did measure it beforehand. Tell you what, let's get rid of the picture, which is not good at the minute. Right, we'll bring this back out. I've got to start putting the ports on it. Right, we'll just bring this out. Alright, I've got to start making doing the things on it. Right, so we've got we're going to have to measure some. So we need to make a D socket. We've got to make some connectors now. Not worried about probably put some holes in it. Tell you what we'll do next, which is easy, is the PCB mounting holes. Let's put them in it next. It's not as easy as it sounds. 6.5 mil by 8 mil. 8 mil by 6.5 mil. Right, okay. Have to draw some lines. So we've got to come in from there, 8 mil by 6.5 mil. Right, so there we need a hole. Looks like 5 mil hole. Got some calipers. What have we got? No. Right, so I think it's 4 mil. Let's try a 4 mil screw in it. Not quite. 3.5 mil. 3.5 millimeters, so. So if you say it's 3.5, we're going to go 1.75. Right, what's that? $3 mil. Oh, we're not showing precision. Thought I set this once. Right, I've got to find a setting. Where's this preferences? Right, I can't seem to find it. Not that one. Put my glasses on. Ah, it's not loaded, that one. Let's take that one out. It's not loading, and these PC discs, they don't eject. Don't know why. I've got a Zulu SCSI in this one. It's going to go straight into Workbench. Let's reset it. Right. It's alright, I'm trying to find... Where is it? It's got a setting. Tools. What is it? Model info? No. Model info. Units. We seem to have defaulted back to... Yeah, we've defaulted back to... That must be per... That must be saved per... Length. Must be per design. Right, so I should be able to measure that now. What have we got? 3.5, yeah, that's it. Okay, so that's one hole. Honestly, so what I could do, well, we got the board to try in, so we'll mill out some of this stuff, and don't know if they've kept to anything, any standards. Let's have a look. I think they keep the design similar. It's awkward to get the ruler on it. It'll take a while. 8 mil. Yeah, 8 mil. So it's the same depth. Right, so between hole centres now. Right, so between hole centres. Or the end of the board. Let's go hole centres. So 2025. Right. 2.5. Right. So there's another one there. Yeah, this only has to be done once. 1.75. Right. So we've got that fixed in, and there's 2 more over. I suppose we better do the rest. It's gonna have to be refined a few times. This is. Oh, time. Right. Yeah, just have to be refined a few times. I might have to print it out or something, or CNC some scrap and. Yeah, overlay some design over to it. I did have a look. Spent a while trying to find something. If it was an Eagle CAD, I can pick it. You can pick up a designing KiCad. But if it was an Eagle CAD, I could convert it straight to the. I've got a utility to just convert it straight to, as I've done before on some of my other projects. Right, anyway, I should get the rest of these holes done. So 117. Right, so 117 from there. 117. Another hole there. Looks the same setup. Luckily they've kept everything the same. 1.75, so that's 3.5 mil hole. Right, there's another one. Oh, something doesn't look right. Oh no, it's about right. Right, next one. 76. Right, there's another one at 76. What I'll do is measure these from both sides. Once they're measured from both sides, I can compare it. A lot of stuff will be lined up with each other, so I can always move it. It's never the best way of doing it. Like for instance, if I go from the centre there to there, that's 14 mil. Let's see if I got 14 mil. I've actually got 16mm. I got 16mm on the correct one, on the real one. Let's see what I've got going back to the next hole. 91mm I've got from there to there. That's 90. So them two holes straight away. Well, that one needs. Hang on. Right, let's just do that. So that's 14. Let's just do it. So I say it's 15 and a half, I say it is. 15.5. So let's get rid of this one. Yeah, this is quite crucial to get right. And we said that one was 90mm, and I think I've got something like, yeah, I've got 91mm there. 91mm, so let's move that around. It's not the best music playing in the background. Anyway, let's find something else. Oh, that one came out. Well, let's put that one in. Right, so yeah, the whole idea is to model this board. I've got an idea as well. I've got in here somewhere. Let me just get them. What did I do with them? Can I reach them? Can I even reach that? That's high up. Anyway, I've got a rounded, an oval Lviv board for a chip memory. Anyway, I thought about amalgamating that with a ROM switcher. So you put it in, you put your mod in, but it also doubles up as a ROM switcher, and it's on one PCB instead of if you're going to do the work, you might as well make it reach over basically and sit in your ROM or your ROM socket. Do a bit more with it, you know. Anyway, lots of ideas. So we've got that to there, so let's have a look between there and there. 116mm. Right, 116mm. I'm just going to make sure I've got 116mm there. It's only rough, you know, rough. 116. It's probably more like 117. Yeah, 117 I think it is. So let's just modify that. Yeah, holes and connectors is all we want. Eventually, what I might do is, once I've created one of the edge connector slots, we could put them in, because we'll need to line that up with the slit in the background. So we're going to get in the back of here, this back panel will have a milled out, either a milled out slit for the car to slide into, or we'll just mill out a separate piece of plastic with a slit in it, and we'll pop them in just like they do in the original one. Anyway, right, so I've got that there. Let's just measure that. So we've got 117. Looks about right. So from that one to the first one there, is 20,202. So from this one to there, 215. Well, let's just measure the corner again. It's difficult to measure. 6mm. Seems to be 6mm from there. 6.5mm. Ah, so yeah, I did go a bit crazy. So if I go 6mm. Let's get that right, because hopefully some of the other holes will be projected off these. Okay. What's this play? Oh, not Iris, is it? But I don't know what this one's called then. Yeah. Right. So anyway, we've got those 4 holes at the back, no, front, that is, that's the front holes. And it looks like there's some more holes. Looks like there's one more hole halfway down that's projected off it. Is it the same distance from the edge? 21? No, it's not. So we'll have to do that one separately. So from the edge, 21, 20.5, difficult to do. $20.5. Right, so let's just, yeah, it's just going to be quite boring. But feel free to, in the chat, just to put any ideas or any help or anything you'd like to see in there. No problem. So I was just trying to get these holes in. Right, what have we got? 15. 15.5. No, I think it is the same actually. It is the same. So, hole between centres. Okay, edge of the board then. Go to the edge of the board. 165. Right, 165. Let's do 165 from here. 165.5. Right. So let's measure between there and there. 1575. 1575, yeah, it is. 1575. Right, so there's one more hole at the back of the board. It looks like it's in line with that as well. Yes. So a hole between centres. Okay, so it's 157. 157. Let's say it's 157. 157. Right, see how. Right, just measure it from the front of the board. Yeah, it looks like 7. Looks like 7mm from there to there. 6.5. Let's have a look. Have a look. Definitely looks like 7. Okay. So what I'll do is I'll go 7mm. Is it 7 or 7.5? 7. Okay, we'll go for that. Right, let's just save it. Okay, so we've got some holes. Where else have we got hole? One in the middle. There's one next to it. Welcome to Battle... Battle what? Battlestar? What is it? Can't remember the name of this one. Right, there's one further in, so let's go to that one. It's 1, 2, 1. 1, 2, 1 from the side. So come in. 1, 2, 1. And it's in line with that one. Is that 1, 2, 1? 1, 7. Oops. 1.75. Right, so that's 1, 2, 1 from the edge. Between centres, I'll say it's right. That's 105 between the centres according to this. So what we got? 105.5. A little bit out. Let's have a look. Yep, I'll go with that. It looks right. Okay, what's next? Let's have a look. More holes. So there's a hole in the... Yeah, there's one right over the other side. Now let's do the other side. So. Right. Difficult. Difficult. 22.5. 22.5. 22.5. And we're from the edge. 6mm. 5.5. 6mm. 6mm from the edge. What's that? Oh, that's 6mm, so that lines up with the front one. So, which one was it? I can't remember now. 22.5. 1.75. So there's that hole. Right, okay. So getting these holes done. Alright, where's the next one? Down a bit. It's not in line with any other hole across, so that's a weird one. Let's go from the edge of the board. 6, 156. 156 down. 156. Okay, let's just go this way. 190 from the back of the board. Right, what's different? 195. According to that, it's 195. 195. So from here to there, what is it? 151. Where did I go wrong? Yeah, it is 151. So what did I measure? 156. .75. Alright. Oh, can I have a game of this? Let's have a game of this. It's on a a double density IBM disc. Oh well. Just going to show up behind the graphics. Or in the wrong place. Ah, it's gone behind. Wrong. It's one of those ROM things. Oh, won't be able to play that one. Right, let's get another one in. Can't get it out. Let's take it out with tweezers. Oof, come on out, you bugger. Don't know which one it is now. Lost track of it. I can't remember. Yeah, try that one. Right, anyway. So, yeah, it's all got chips on here. I've got me 2 megabyte Agnes to swap over. Right, where did we get to? So we've got a hole there, one in the corner, we've done that one. Let's just measure it again. Oops, need to reboot. Right, so yeah, we've got that one right now, that's okay. Right, where's the next one? There's one hole right in the middle. Suppose we want to get that one next. One 6.6. 165. Let's say it's 165. Nice. Yeah, it's a good one there. More bass. Take it down.
It's going to be a very, very big hit.
Right, let's not get too distracted. Right, so let's find this hole. 165. What's that? Is that 165? It's not showing me anything. 165.5. Where did I get that from? Ah! It's already in line with this hole. Are they in line with that hole? Yeah. That one's literally off this size. So if I go between centres, getting mixed up there. That's right, yeah. So from the edge, circuit board edge, 149 between centres. Actually, it's probably going to be better to turn this PCB over to measure this. So we've got to go over the components. Yeah. So 1, 3, 5, 6, 135.5. 135.5. 135.5. Ah, lost it now. There's too many rulers on it. There it is. Okay, so there's one more on a connector that goes through, one of the legs of the floppy drive or something. Let's sort that one out next. So it's literally 120 mil, 120.5 mil. So it's 120.5 mil from there. 120.5. No, 120.5. Right. That looks about right. Is it in line? It's not in line with anything. It's 9 mil, 8.4. 9 mil. 9 mil back. So we've got to go from there to there. Yeah. It's literally there. What size is the hole? Is it the same size? Yeah, it looks it. Looks a bit smaller if anything. Yeah, it looks a bit smaller, that hole. Oh well. I'll make it the same size. 1.75. Okay, so that's the connector. Any more holes? There's another one at the back. Another one at the back onto one of the COM ports. Serial ports. No, joystick mouse port. So let's get that one in. And that's upside down at the minute, so let's go over here. So I'll go from the edge, PCB edge, to, that looks like 86 from the edge. 86, and it's how far back? 10 mil. Nine mil. 9 mil. It's 9 millimeters depth. Nine millimeters. So why isn't it? If that's 9 millimeters there, what have we got here? No. Yeah, 9 millimeters. So I've got. That's it. And we've got 9 millimeters. 8, 9. Right, okay, slightly inset that one. Okay, right. So have we finished? Let's count the holes. There is another hole on the PCB. Must be where the fiducials, where they manufacture it. They haven't got tabs on them. I suppose I better put them in. Better put them in anyway. Alright, so we've got 5 mil. 5 millimeter from the front edge. So we've got another hole here about 5 millimeter. It's how far in? 15 millimeter from the edge. Alright, so that's that one, and it's Looks a bigger hole actually. I'd say it's 5 mil. Let's try a 4 mil nut in it. Yeah, it's 4 mil. So if we go 2 mil. Alright, so that's that. Oh, we'll have to get them and put them on because they're not in the model. That must be a fiducial mark or some kind of mechanical handling thing. There's also one at the other end. Totally at the other end. Over here. Let's see if it's the same. It's 5 mil, is it? Yeah, 5 million by 5 mil. So that one's 5 by 5. Yeah, and it's the same size. So it's 4 mil. Okay, so we've got that. Is there any more? Oh, one in the middle. There's another one over here, similar to that. Right by that. Let's just measure it. Right, so it's 195. 195 in from the edge. And it's also 5 mil. That looks it. Yeah, it's also 5 mil. So 195. There it is. Okay. Right, are there any more? There's 2 more holes under the Agnes for pushing the Agnes out. I suppose I can include them. No, not at this point. We don't need them at the minute. Right. So in total we should have 1, 2, 3, 4, 5. Oh, hang on. There's one more hole. No, that's not a 4 mil hole, so I don't know what that is. No, that's a smaller hole right in the corner. Better include it, I suppose. Alright, let's so yeah, it's long-winded, but once we've got it, we've got the exact, it's a template to place all our connectors. Right, so what I need now is to work out where this extra hole is. It's in this corner over here. Okay. $7 mil. 7 mil from the edge. And it's, what have we got here? 6 mil. 6 mil. Right, so we've got 7 mil and 6 mil. So, and it's only small. So I'll just have to make it 1.75. Right. Okay, so that's that. Are there any more holes? Let's have a look. Let's count them up again. So I've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 holes. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright, start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 holes. Let's try a count at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What's going on? Just count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 holes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 holes, call that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4. I'm no good at counting. Where are we going to start? Top left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. So it looks like we've got matching holes. Let's just measure. Let's see if we're even close. I'll measure from one hole to another diagonally. Let's do it. Right, so that one there. All the way to, can't get to that one. So I'll go from that one to that one. 104, 149. 149. So apparently I should have from this corner, this hole, to the second hole here, I should have 149. What? No, hang on, I've read it wrong. 449, sorry. Should have 449. What have we got? 44867. Not too far out. Okay, let's tell you what, we won't worry too much. Let's get rid of these lines. First we've got to grab all this stuff. Cut. Paste in place. Okay, now get rid of the lines. Let's get rid of whatever lines we can get rid of. Oops, not there. Any lines we can get rid of? We need to get rid of the lines. The one there. Right. Yeah, so get rid of all the lines. Can't see what we're doing with all them many lines. Don't really need the lines anymore. What we'll have to do is mill out something on a scrap. We can't mill this out in one piece anyway. Right, so we've got let's just have a listen to the audio, see if we're being overwhelmed. What we'll have to do is mill out something on a scrap. Can't mill this out in one piece anyway. No, I think we're okay on the audio. Not getting overwhelmed. Right, so we've got our board.
It's going to be a very, very big hit.
Right, so yeah, let's chisel it out. Let's make it look like a board. Right, is there another demo? Let's have another demo. Yay! Not the best demo, that. Welcome to a weird live stream. Well, creating an Amiga B2000 motherboard from scratch. From scratch. We're going to use the motherboard as a template to create holes for our studs. Right, so we've got that. We can colour it different. What colour? The PCB? Green, I suppose. Let's have it green. Yeah, we'll have it green. Let's find a green. PCB colour green. Like that, maybe. Too green. Too dark. Too light. Can't seem to win. How about that? Is that PCB colour? Is it, isn't it? That's the one. That'll do us. Yeah, it looks like a PCB. Okay. Right, now we need to create some connectors. So, next one. I'm getting thirsty. Camera slightly off. Oh well. You see the monitor, you don't need to see me.
Insert disk 2.
Very good. I can find disc 2. What did I do with? Did I do disc 2? Oh, I didn't do disc 2. I ain't gonna be able to do disc 2. I didn't do disc 2, I don't think. Or did I? I can't remember. Never mind. I'll tell you what, we'll have some Star Wars. Star Trek. Let's have some Star Trek. Alright, here we go. Let's have some I've got Star Trek. Right, so PCB. So we need to create some connectors. So luckily they're all D types connectors. And are they all? Right. There's one Oh, big motherboard this is. Anyway, I'd have killed for one of these in the past. Right. So what I need to do is model the connectors now. I suppose I could find one already done, but I need to be the exact one that's on here. They're rusty anyway. Look at that, rusty that. Yeah, it's going to have to be replaced. I don't like rusty connectors. Right. So we've got 1, 2. Yeah. I suppose we do the D plug. 9-pin Ds first. We'll do. We'll model them first. Let's model the 9-pin D, the Foxconn. Have you read the docs? Do you want to read the docs? No. Want to see the intro ending? Yeah, go on. Right, let's get back onto it. So we're going to model a connector now. It just so happened to be round the back here. So let's just make one. Let's just measure the size of it. Size of the connector. Right, so it's 30. Is it 30? Let's just. I'm seeing 30. Yeah, 30 mil wide. So we could do it on here, couldn't we? Yeah. So 30 millimeter wide by. The depth of it is 2.5, 2 mil. Two and a half mil. Does it matter? Yeah, 2.5 mil. 2.5 mil by 2.5 millimeter. Right, and then the height. Here we go. The height of it now. I'm butchering my could short this out if I'm not careful. Right, 12 mil. 12 mil high. Right, 12 mil high. So let's 12 mil. Right, that's the plastic collar. Now the back is another piece. Right, let's just have a look at that. 8 mil. Yeah, 8 mil, 8 mil. Or was it 7.5? Say 7.5. Okay, so let's spin it round. So we need to do 7.5. We seem to. What's going on here? Enough memory, copy disk to RAM. Yeah. Okay, and we've got to go 7.5 this way. Right. Okay, and we'll slightly step down. Need the height of that one. The height of that. Oh, I can't see with these glasses on. Right. Oh, it's awkward. Hang on. What can we see? $10 mil. 10 mil. And it comes back from there 8 mil. Comes back 8 mil. So we've got 8 mil back. No, let's not have a marker. It's 10 mil up, so that's 12 mil, so 10 mil. Right, we need to pull that out. Oh, we need to draw a line. Does it go all the way down? No, it doesn't quite go all the way down, does it? No, it's... What size is the connector? It's awkward, it keeps spinning. I'm on a stool, it's spinning. The lighting's not good. Looks like 2.5 mil, 3 mil. 3 mil, let's say 3 mil. 3 millimeters from the floor, so let's go 3 mil. Problem, we wanted that, not a line. 3 millimeters, right, okay, so that's that. So we need to draw. Right, they come out at different depths. Okay, so I can pull them out. Right, it goes out all the way to 12 mil. So it's 12 mil from the front. Yeah, 12 mil. So I need to pull them. I need to draw a line there. And draw there, like that. And we need to pull it out to 12 mil. So 12 mil. 12 mil. Right, and then we need to pull that out at oh, hang on, that's too much. 12 mil minus the thickness. 12 mil minus the thickness of this. Minus 2.5 mil, so we need to push them in. 2.5 mil. 2.5 mil. Right, and then we do to bring that out 8 mil. 8.5 mil. So we bring this out. Oh, we need to draw a line. Is there a hollow underneath? Actually, it doesn't go all the way down, does it? No, it doesn't. It only goes about 4 mil. Say 4 mil from the top of there. So undo, draw the line, undo. 4 mil from here down. Yeah. And then we've got to draw a line around it. Pull that out. What did we say it was? 8.5 mil. 8.5. Right. So we're doing a Foxconn 9-way D connector at a correct height off the PCB with a bit of luck. Screw holes and flush with the front. Okay. Yeah, that's slightly set back, isn't it? Right, then the pins go down. There's 5 pins you can see at the back. Right, let's have a look. Does that look right? Yeah, looks right. So might as well do the. Are we going to do the 5 pins as well? Are we going to bother with the 5 pins? Nah. let's not bother with the 5 pins, let's just get the size. Right, the hole's next. Now the hole is, that's 12 mil, so the hole is at 9. So back 3 mil. So 3 mil. And are they centre? No, they're not quite centre. Why are we doing holes? I don't know. That's 30 mil. 3. Yeah, 3. I think they're 3 mil. 3 mil. 3 mil. And we've got some holes, which are, what size are holes? Only small. So let's set it to 1.5. 1.5, so 3 mil diameter holes. I'm going to punch them through. Might as well. Let's just save that. Right, so we've got, looks a bit weird there. Why does it look weird? There's another row of pins inside. There's a bit of plastic as well. Can't quite see the plastic, but doesn't really matter. Let's just put something there. Let's put something there, so we've got something to work with. Right, can we pull that? Yeah, section. Right, so we want to pull that section. Let me have a quick depth. That looks about 3 mil. Well, we've got 8 mil. Let's say it's 3 mil. Say it's 3 millimeters. Okay. Then you got your pins. I suppose we're going to do the pins. Won't look right without the pins, will it? So might as well model it. Alright, so from there we've got, I wonder if they've done them by the inch layouts. Have a look. No. No, hang on a minute. Just try and get that. So that's spacing. There's one in the middle. They look about 1 mil, 1.5 mil. So, and they're coming out from the middle of the thing, which is 2 mil down. Oh my god. Right, hang on. It's crazy. Can't see it. Not the best tool for this. I think we're going to have to guess, as long as they got the flushness on the front of the board and the actual holes and the rounded bit at the front, right. Oh, it's got to be right though. So middle, say it's 1.5 mil. 1.5 mil from the centre, and it's, how far deep is that? Can't see off this drawing. 4 mil, 3 mil. Let's say 3 mil. 3 mil down. Let's put a gap in it. Alright, let's do it. So that's the right size there. What can we do? 3 mil down. Yeah, and there's a gap, and what size is the gap? Oh my god, say it's a mil. 1 mil. And the depth of it is... Depth of the gap. This board, I doubt this board will work. I'll probably shorted our chips out on it, but anyway. 6 mil. 6 mil. Yeah, this board probably won't work, but that'll be fun to make it work again. So let's just go from there to there, and from there to there, and there to there, there to there. So anyway, we need this, and we can duplicate this with a bit of luck. Are the connectors the same? Not quite. Some of them are, some of them aren't. Yeah, most of them are the same, so that's good news. Right, what did we say that size was? Can't remember now. 6 mil. 6 mil. Should have called this video "Man Wielding Ruler." Right, so anyway, we can pop that. Why won't that let us have it? It will, but not that. Oh well, let's try it. Has it done it? Yeah. So we've got that. So our things come there and down. Now do we want to see the legs underneath? Am I really going to go to that distance? Am I going to model them like that? I suppose I better do something. They're 3 mil. 3 mil distance. So we need 3 millimeter into there. Right, we need the center of this. So we need the that's the center. No, it's not. That's the center. Right, so from the center we need to go out 0.75, 0.75, 0.75. Let's get rid of that one. Right, that's our center pin, and so let's draw the center pin. It's going to go all the way to the floor like that. Actually, it'll go right through the board, won't it? So if we measure that, let's measure that from there to the board. 7 mil, 1.6 mil board with a bit sticking out the bottom, say 1 mil. So that's 7, 1.6, 8.6 plus 0.4 and 1 mil. Let's just say 10 mil, shall we? Let's just say 10 mil. 10 mil. Right, let's have a look. It should be sticking out by about 1 point. Yeah, that's okay. Right, so we've got that. Let's do another one. 10 mil. Right, so we've got a leg there, sort of. So we need to go across there. We don't need the centre line anymore. What we do need now is a bottom to it. Drawing that up. Okay. We've got a surface, so we need to come. Need to give it some depth. So what we need to do. Can I grab that? No. If I go like this, I can. Right, what have I got? Cut. Okay. Paste in place. So right, yeah, we need to just watch what we're doing now. So I'll make a component. Right. Make a component. We need to go into the component and grab this there. No, what's happened? Oh yeah, go into the component and grab that off. It's not letting me get it, is it? Cut. Paste in place. Okay, so that's okay. I need to give it some depth, so we need to go. Oh, no, we need to get rid of that. We need to bring that out by, let's say, 1 mil, 0.5 mil, 0.75. Oh, we crashed. Please remove the data disk and press return. The data disk. Right, what's it want that for? Starting the game. Right, it wants me to remove the data disk. Come on. Right, so we've crashed the program. Let's open it up again, see where we got to. Right. How much of this did we save? Oh, not too bad. Right, so we need to go into that. We're in X-ray mode. We need to grab it. No. What is that? Oh, we've already got it. We've already got it, so I need to 0.75. That's it. Okay, so we've got that. We can get rid of a bit of Star Trek. Greetings to all Trekkies. Oh, bit of background. Have a bit of Star Trek background, why not? Right, how long have I been streaming? Hour and 39 and no drop frames, that's alright. Doing okay there. Right, let's get this over there and get myself square on a bit better, get comfortable. Right, so we've got one pin. We seem to have lost our surface there, so we need to get that surface back. Why have we lost the surface? I suppose we could just do that. No, that's not going to do it. What have we lost? Oh, have we... No. Why are we not getting... No. Ah, that's why. Okay, so we got it back. We can get rid of that line, and that line, and that one, 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 that one, that one, and that one, and that one. That one, that one, that one. That's it, we got rid of all the lines. Oh, we have got now. What have we done to our... We seem to have weirdness going on here. We've got no side to it for some reason. Well, let's just go into it. Find out why we got no side. Oh, is that it there? Ah, I know why. These aren't actually cut. They're not in the model. So what's that in there? So that can go. And so can that. Right, and there's something of a crossover going on here. Weird. What we're missing? Ah, there it is. And we're also missing something here. Ah, there it is. Right, are we back to... Oh, no, we're still missing a bit. Okay, so we're getting it back slowly. Right, what about underneath? Can't see underneath. Not at the minute. Right, so we've got that back. We want another... Why has this gone funny colour? Oh, it's because we're not in it. So we'll save what we've got. I need to make that a component somehow. Oh, hang on. Have I got it? Have I selected all of it? Yeah. Alright, so we're going to make that a part component. It's a pin. Right, so we need more pins. So, are we going to be accurate? Does it need to be accurate, or will we just space them out? Right, let's just copy one over here. Where do we need to put it? So we've got... Oh, if we have one there, and we're going to need a one in the middle. That's nice. Okay. Another one there. And another one there. It just happens to jump to the right mill. Okay, so that's that. But we also need some inside, which are spaced. I need to copy them. Let's put them. Let's put them there and there and there and there. That's our 9 pin, but we need to move them in and make them smaller by a certain amount. Let's to make them smaller, so right, that's a pity. Pity I went and did that. So make it unique. Do we want to make it unique? Maybe. Let's bring this down to just like that. Can we copy that? Right, so we've got them. We need to bring them in to wherever they're supposed to be. 3mm, we said, wasn't it? We already said it was 3mm. So we need to grab hold of them. And they're 3mm from 3mm from there, so we're going to take them in 3mm. Okay. Now, have we got something that looks like a D? Yeah, we have. Okay, so we've got that. And these just fold round there and they go in, don't they? So them I'm not worried about because you can't see them. These, they're going to be silver, so we do need to go into the connector, so we need to draw some lines. Oh no, don't want that. We want a line. Just like that. Right. Okay. We set that, so we need to come down 0.75. Probably we need to grab that, and that. No, need to come out of there. Need to grab that. Okay. So grab that, and that. Cut it, come out and go into this and paste it in place. Alright, and now we should be able to carry on drawing it. And go over to this. We're not going to be able to do it like that. No, that wasn't right. Yeah. Oh dear. Right. Let's just, I've lost it now. Where's he gone? No. That didn't turn out. So from here to there. No. Basically, what I need to do is not stop it in the wrong thing. Let's just come out a minute. Let's just move it out of the way so I can see what's going on. Alright, let's bring this out. 100mm. Oh, it's got it over there. Right, okay. Yeah, we need to make this first, so I've gone a bit stupid there. Oh, just hadn't finished it off. Okay, let's finish it off. I've got piece missing. Okay, and go from there to there. Right, so should have a pin now. Have we got a pin? Yeah. So we've got a pin, but we don't necessarily want this. Okay, we just want a bent pin. Okay, so we've got our bent pin. That'll do. Right, okay. It's our component, so that's good. Let's move it back into place. Oh, come out first. Move it back 100 mil. Right, so go over to here. Okay. Let's see if I can't reproduce that. Oh, it's done it for me because it was a component. That's fine. The rest can stay as they are. Right, so we either go up slightly. Tell you what, I don't want to go trim all the lines up, so what we'll do is we'll take them all up. We'll take each one of them up very slightly, cheat a bit. We'll go up 0.5. That'll do. Now, have we got something sticking out still? Yeah. And we're going to have to go with these ones up 0.5, otherwise they're going to look weird. Right, okay, everything should be good now. Shouldn't really moan too much that we're gone through. Can't really see it anyway. So we've made ourselves a connector. We're in the depth of the plastic. That's gonna be okay. Right, so we've done that bit. Right, so well, let's group it. Have I got them all yet? Group. Oh no, let's group it. Right. I should have made a component really. Undo group. Create a component. Okay. Right, so we're missing something. 2 holes for the nuts next. Let's measure those nuts. Are they in line with that? They're not quite in line with that. Right. No, they are in line. No, they are. They are in line. It's just the screws that they're in there aren't in line. Don't look like the right screws. Looks like someone's replaced some of the screws. Someone keeps calling me. Captain, shuttle repair complete. Oh, fair play. Oh dear. Right, so we need... Let's just have a look what we got there. Right, it's halfway up the connector face. So, halfway up here, we need... That's 12, that's so 6 mil. We said that was 3 mil, didn't we? So 3 mil. And 3 mil. We need a small hole. It's only small, isn't it? What is it? Okay, so it looks like 2 mil. 2mm fixing. Is that right? Going a bit over the top now, really. We better do it though. Or should we just make the hex nut? Let's do the hex nut, ignore the rest. Maybe 5mm hex nut. 5mm, and it's can't see. 5mm. 5mm, my 5mm deep, 5mm hex nut. Let's get a hex nut. Let's go like that. Say 2mm, 2.5. Right. Let's draw it out. 5mm. Let's have a hole in it. The hole's going to be 2mm, 1.2 2mm, 1mm. Okay. Right, so we've got that. And we need to have a thread through it. So we'll have to grab that, make that a component. Oh, we need to move it out. Move it out, I don't know, say 100mm. Move it out 100mm, it's got to go depth through there onto a nut. 2.5 with a 1.5, a 2mm nut. 1.5, 2mm nut, so 2.5, 3, 4.5 hole in it. 4.5. So we'll put okay, 4.5. Right, I'm not doing threads, so we've got that. We might as well do the nut to go on it. Looks like a square, flat nut, so similar size to the slightly oversized. Let's just do one. Alright, let's just say it's what is it? 4mm by 4mm. Or is it 5? No, it's 5 by 5, isn't it? I don't know. Let's just say it's 5 by 5. And it's 2mm thick. Is 2mm too much? 2mm? 1.5mm. And it's got a hole in it. Come on, you can do it. Right, and it's a 2mm. Did I say it was 2mm? 1mm. Is that the same? Can't remember. 2mm. Let's put a hole in it. Right, that's it. So we've got, that's a unit. This might as well be a unit with that. I don't need separate things, so. Right. So we've got, well, I'll tell you what, I might want to reuse the nut, so let's make a component. We can group these together. So let's just fetch that down here. Like that. We need it, stick it out. So we've got a 2mm there, so we need to bring that up to there somehow. Is that going to be easy? On the line. It's on the line, but it's not on the line, if you know what I mean. Undo. Right, so we're there, flush. Okay, we can just measure. It's where your maths comes in, basic maths. 3 mil, so we only need to move it in 1 mil. We don't even need a line for that. Okay, so we've got that. Right, so we can make that as a component. Make it a component. Right, so we need to move it back by 100 mil. Right, and it should be back where it's supposed to be now. Right there. Okay. And we want another one. 24 mil over, so we need to copy it. And say 24 mil, and that's it. Okay, so we've got our two things with our nuts and fixings. Now, for some reason, we're not showing the edge of it because we're flush level with it. So what we're going to have to do is move this back 0.1 of a 0.1 of a mil. No. What went wrong there? Undo, move. Something went wrong. 2.5. It's not 2 mil. That's why. So we need to move that back 0.5 of a mil. That's it. Okay, and there, looking like a connector. Just need the D bit. We're going to do the pins? I don't think so. I'm not going to put pins through this side. Although, probably could do, but do I want to go to that level of detail? No, not really. Right, let's just get rid of these lines. Okay. So we've got that. We need to colour it a bit. Before we colour it, let's do the D on it. What? Right, let's find out how to do a D. What we got? So we've got, oh my god, top to the bottom is 8 mil. 8 mil. So we've got here, what we've got, 12 mil. So we've got 12 mil, it's 8 mil deep. We need to do 2 mil down and 2 mil up. I need to measure the width of it. Why don't I just get a connector out and do it so that man handling the board? I could have done. Right, anyway, actually this connector is slightly bigger than what I thought. It's 31. 30 and a half, that's close enough. Right. So it looks like it's 6 and 6 at the top. 6 and 6. Right, so we've come in 6 mil and across 6 mil. Okay, let's do the bottom bit. How far is the bottom bit over? It's in a bit, isn't it? It looks like it's in the middle. 7 mil. There's not much in it. Six mil. Okay, let's say 7.5. Yeah, let's say 7.5. Right, okay. Right, here we go. 7.5. 7.5. Okay, so we've got a line. So what size is that to there? 1.5. So if I say 1.5. 1.5. If I draw a line then from there to there, then I do from there to there, then I do a measurement of 1.5 down and 1.5 up, and do a line from there to there and there to there. Now I'm not going to have enough segments to do a curve here. It's going to complain about that. Yeah, not enough segments. Right, I knew that. So how did I get around this before? Did I do one of them? An arc. Can't remember how I did it now. How did I do it? Yeah, it doesn't like to do such things, but does it have to be that accurate? Needs an arc on it. I can't remember how I did it now. Circle, maybe. Can I get in the middle? No. What's that like? Not good. That might do it. Oops. Right, that's something weird there, isn't there? I only have to do this once. Well, sort of once. Right, okay. Let's grab that, copy it, paste, I'll paste it here, flip it, flip along, that'll do. Okay, we've got that bit. Is that going to work as... Can I just paste it and paste again another one? Flip along a different axis. Didn't do anything. Undo, flip. Flip along blue direction. Right, is that even going to work, or is that just going to look totally weird? I guess looks weird, doesn't it? Does it matter? Yeah, it matters. Okay. Didn't work out. Maybe undo flat script, flip, undo paste. So if we flip it, reverse, flip along the red direction, then we flip along the blue direction. No. Flip along green direction. Didn't make no difference. Tell you what, I'll just get rid of that. I'll do what we did again down here. And just... Alright. Yeah, it's not quite right. It's not quite right, but does it matter? Oh well, it's got a bit of a notch on it. Okay, so we'll compromise. Compromise or leave it? I don't know. Take that off. Explode the curve. Take that off. That'll do. Oops. Right, so we've got that there. I'll copy that. Copy. Paste. I keep knocking the mouse on. Let's flip it. Right, let's bring that up to. Oh, let's get rid of that. Okay, we've got our D. Right, okay, let's get rid of these. Hopefully we can use this one to create or other size Ds as well. Right, so we need this, yeah, we got that. Let's say the D thickness is, it's not 1 mil, is it? Let's say it's 0.75. So if I do that now, oh, we've got no surface, have we? Oh, we need to create a surface. Why won't it let me get that? Let's see if we can get it. Can I? Yeah, I can do it. 0.75. Right, that's it. I'm not going to do pins. So what I need to do now, still haven't got a surface. Right, okay. How do I... Oh, I've got a surface there, but none here. Right. Let's see if I can't... Repair, flatten. Oh, it's round it. Right. Tell you what about if we cut them off? Cut. Paste in place. No, I still haven't got a surface. Got the middle surface, so it's not liking something. Something's not quite joined. What's joint? What's not joint? No, it looks okay. Right, okay, let's put a piece in, see if it gives us a surface. Now, have we got, yeah. Okay, so we've got a surface. So let's have a look in the connector. What have we got? A dark piece that's inset. It goes into it more, does it? Flush with the back. It looks like it's just flush. Okay. Right, it comes out. What? Let's just see how far it comes out. It comes out. 5 mil. 5 mil. Let's push it out. 5 mil. 5 mil. Right. Okay. Okay. I'm not going to bother about the pins at the minute. So that's close enough. Right, so we need to make this into a component. I need to group the whole thing together. No. Undo group. Make it a component. It's a component within a component within a component. Right, let's colour it now. Let's give it some colour. To do that, let's move it out of the way. Let's move it so we can work on it. Right. So what we're going to colour first. Just colour the basics first. Black plastic. Right, so this is going to be colour. Synthetic black. Do we want synthetic black or synthetic surfaces? What about that? Oh, why have we got that there? Why is that there? Don't know what happened there. Oh. Right, we shouldn't have got rid of that one. What we should have done is got rid of this. Oh, it's there. Oh, just got an extra surface on it. No, we haven't. Intersect. No. Right, okay, let's start again. Oh no, it's going to make it the same colour. We want that, but we don't want that top one. I don't get that. So if we delete that, what happens? We lose the whole thing. Okay. Undo erase. Let's erase the bottom one then, if we must. I know you get an odd, funny glitch now and again with this. It's not part of the model. Intersect the face with the model. Now we've got a different colour. I knew we would. So let's step back a bit. Undo. Let's undo the paint. Right, have we got... Yeah. Right, so we've gone crazy now. Right, so we've got that there. We need to lose that. Intersect the faces with the model. Push that back through. And we've got our colour back. Then paste this colour on. That's it. we got? Have we got? Yeah, we've got it. Almost. Right, okay. Right, oh, got to see a bit there, that's weird. Anything else? No, that's alright. I suppose we could bloody paint that, really. Yeah, might as well. Makes sense. Right, okay, so that's all the plastic bit. Now, this bit has got to be black. So we could paint that. Oh no, that's part of the other thing, so we better come out of that. We could lose that. Don't need that. That's better. Righty-ho. Okay, so we've got that. Pins. Need to colour these things now. Steel. Right, let's find some steel. Steel, metal. What about that? That one. No, we've done something wrong there. Oops. Alright, this is quite monotonous. So we've got our steel. I suppose we have to make this steel as well. Let's make it steel. Let's make it steel. Right, okay. Right, what we got? What have we done? I've done something wrong. Undo close, undo close. Undo close, undo paint. Undo paint. Undo paint. What am I undoing? Undo paint, redo paint, redo paint. Right. Okay, I can see what's happening. We're stuck inside it a little bit, so that needs to come forward a tiny bit. 0.1. No, why are we looking at that? Where's my line gone? Hang on. What's happened here? I've gone stupid, isn't it? Undo, close. Undo, move. Undo. Undo. Undo, 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 undo. Undo, 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 undo. Undo, undo. That's it. I made a mistake the first time round, didn't I? Right, so I need to paint that, 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 that. Paint that, that, and that. And that, done that. Right, so everything else should be good. Right, something wrong with the edge. Where's my edge gone? Why have I got no edge? Undo close. Right, Alt and backspace. Okay. Right, so we're back to there. So why does my edge disappear? So if I paint that, and that, and that, and that, I come out of it. Yeah, everything's good. Go back in. I paint that. No, don't want to paint that. Paint that, that, and that. That's okay. Now if I go back in and paint that, okay, that'll do. Right, that'll do. Okay, so what have we... Yeah, we haven't got no fixings there. I don't care about them at the minute. Right. Yeah, that'll do. We've got to paint that yet, so... Right, let's paint that. That. Do we want to paint all that? I suppose so. What's happened to the Starship demo? Oh, it's quit. Alright, start again. Don't know what's happened there. Probably realised I wasn't doing anything with it. It decided just to ignore me. Close the program. Right, oh, we done. We haven't done the inside, does it matter? Don't know, let's have a look. Right, we've got something weird there now. Look at that. We've lost the outline. So I've got to go backspace, backspace, keep going back until one little mistake and it all gets upset like that. Tell you what, I'm not going to bother with that. I'll leave it as it is. Right, so I've got a connector. Let's save it all. What we got? Two and a half hours to make a PCB, holes and connector. Right, let's put that onto the board approximately to the nearest 0.25 of a mil. So center of it. Right, so where we're looking. So 70. I don't know, it's awkward. Let's say 74 mil. 74 mil. Let's do a line. 74 mil. Let's grab that. And take it from the corner and put it there. Let's have a look. No, that's not quite right. That's better. 74 mil. So let's just double check it. 74 mil, yeah. And the gap between the next one is 114. 114 from the end of the PCB. 114. So we need another one of these. Another one of these. And we need it here. On the line. Oops. Yeah, that's it. So we've now got our 2 connectors. Right, so we need to group it all together. Group or make component. That's it. So we've got our 2 holes, 2 positions for our connectors. So if we grab the whole PCB now, we've obviously got to do the back as well. If we bring this into here. Right. So let's drag that to the front, and we need to grab it by the center and put it in the center. So we grab it by the center, not that center. Where's the center? No, it's gonna have to come up first. Alright, and we have to grab it by the center. Where's the center? It doesn't know, does it? Right, I'm gonna have to go for an interim, so I'll be back in a few moments. We're back. Alright. Star Trek back on again. Okay. Right, where the hell? Let's have a drink. It's thirsty work, this is. Right. So I've got a lot of money's worth of equipment here. £225 main board. Working, but I haven't even tested it yet. Just so we can stop. Don't have to take my working one apart. Anyway, which makes me need a case for it. Well, I got a case for that one, no case for this one. But I want to make a facility for extra stuff, to extra ability. I don't want to mill out or drill out my original case and add switches and things. Anyway, I've got another interesting project, a wireless internal switch that plugs into, so you use one of your slots, plugs in, takes its 5V from there, and you have a web interface on your phone which you switch on and off different things that you need to boot from. So that the switch, it'll only change, remember the setting, but it won't switch it while you're powered up. It'll wait till it reboots before it reads the parameter. Hang on. Yeah, so it's going to have to either be quick or hold off the reset. Yeah, so there's that to it. Depends how quick it is. Probably have to hold off the reset till it's switched. If it's doing it via relay, would have to boot up and then switch it. That might be too late. That's just like switching it while it's still on. So yeah, we're gonna have to hook a reset line up to it. Maybe we can get a reset line off one of the connectors. Anyway, there's all that to sort out. Right, let's get back over to this. So what I'm trying to do is see where this needs to line up. I'm trying to grab the middle of the board. So there's the board boundary. And I should be able to grab the thing by the middle of the board, I think. It's normally the case. That's not the middle. Where's the middle gone? Is that the middle? No. I think that's the middle for some reason. No, it's not the middle. It's because it's getting confused. Why have I selected that? Right. Let's try again. Somewhere is the middle. Isn't there something you can find the centre? I thought you could find the centre. Anyway, so we'll have to do it manually. I'll do it manually then. Right, so 416, so 208. 208, so let's 208. Right, there's your centre. So if we grab it by that, and we could move it, we'd have to, I can't line it up. Can't line it up because it's trying to push me there, so that's not good. So that's not going to work out. So right, it's going to have to be made in two parts. Oh, this is the PCB. Why has that one gone right through that middle of the hole? Could that be our centre hole? Fiducial, I bet that's a fiducial to indicate the centre of the board. Or maybe not. Let's have a look. Oh yeah, could be. No. No, it's not. It's fixing all. Anyway, I've got a hell of a lot to do on this, so I just want to position it in place somehow. Tell you what, let's go around the front. Let's take that silly line off. Let's take up the sides off. And the front. And lose these. The badge. The drive bays. Can leave that there for a bit. Right. Okay. So we've got 6mm. It's going to have to be milled out to allow for them to stick through. It's going to have to be an area, when this is milled out, it's going to have to do pocket so these can be plugged in. Right, so we've got everything. Oh, we can remove. Let's lose the lids. Right, here we go. We can get to it now. So we know we're 418 on the size, 416, and we know we're 445. Let's bring up a calculator. So 445 minus 416 equals, divided by 2, 14 and a half. Right, 14.5. 14.5. So if I grab the board by the corner, bring it down to here. So we're okay there. We should be on the line over here as well. Yeah. So we're lined up that way. Now we've got to decide. This is the inner section. These need to stick through. We've only got 5mm there. We've got a 6mm polycarbonate sheet to go over. That's not the best idea. So there's a reason the front plate's made out of steel. So what do? Do we mill out a pocket? Well, let's see if there's anything sticking out of there. No, nothing's sticking out. So that needs to go flush. Oh, they do stick out. Yeah, they stick out because the keyboard connector is flush with the board almost. And these stick out, so they actually stick out over the end, like they're doing just now. Yeah. Yeah, so we've got to do keyboard connector as well yet, but so they will have to just butt up flush with it. It's gonna have to butt up flush, so let's try to butt that up flush. On the line. So that's butted up flush. Right, and these are flush over here. Well, they're flush there, but you can't see them. But if we go X-ray mode, we can see where they need to come out. So I notice we'll have a keyboard connector here, and we seem to have, the way I've built it, space for other stuff here. without not doing it on purpose. So just looking at the real thing. No, the real one has got no space because we're we're sat too low. You see, the motherboard doesn't sit that low. Let's sort that out now. It's not sat flush onto the metal like that. It's flat sat up. So we're gonna have to go up. We're gonna have to work out what spacing we want without taking the lid off this and measuring it. I'm just gonna go off a standard 11mm, I think. 11mm brass spacer. Yeah. So let's go up 11mm. That looks quite high. Why does that look so high? Is that right? Did I do it right? Yeah, 11mm. Maybe they're not 11mm. Yeah. Don't know. Let's say 5. I don't know. We can adjust that. Let's not go up 11mm. Let's go up. Let's say 5mm. So we're up 5mm. Let's get rid of the lines. Let's have a look at what we're looking at now. So yeah, we're almost good. Because we've got the back of the plate to work out yet. X-ray mode. Yeah, we've still got space on this one. Yeah, because that's the... Hang on, let's put the front plate back on. Yeah, there's an overlap there. But yeah, you could put could put an SD card or compact flash or something in there. Keyboard connector next. Anyway, so that tells us where it needs to be. So if we want to, we could... How does it work out on the real one? No, it's just a big square. Just a big rectangle cut out, so yeah, you've got enough. Yeah, so I can see what they've done there. So what we'll do is, we know these are accurate enough, so what we're going to do is let's go and we need to take off. Right, inside, inner front, move the inner front, right. So the inner front's off. We need the rectangle. What's it showing? Actually, it's showing quite a lot. It's showing the whole of that plus about 2mm. Looks like 2mm. 2mm, 3mm. 3mm from the sides, so we need to draw something actually. Let's draw something based on that. So let's go 3mm that way and 3mm that way. And I'll go 2mm tall and 2mm down. And if I draw a rectangle there, that's basically the cutout with a rounded corner. So let's should we give it a rounded corner? Can we do that? Yeah. Right, let's just go I don't know, 2mm. 2.5, 2.5, Too large. Number of segments too large again. Right, it's too large. So, okay, we can do it that way. Right. 2.5. We'll do it another way. Okay, so we've got that. Let's get rid of these. Okay, let's grab that. Oops, can't see what I'm doing anymore. Right, it's just that bit we want. Cut. Oh. Yeah, cut. Bring in the inner front face. Paste in place. Swing it round. Right, move it forward by. Oh, we could just. Yeah. Oh, we want another one. Let's do 2. Copy. Actually, we could do, if we know how far away it is. Let's measure how far away it is. 40. Let's just duplicate it and say 40 mil. Right, that's not quite good, is it? Have I got hold of it? Let's hide the. Hang on, we need to hide the PCB. Hang on. Right, let's make a PCB. Oh, we got a PCB. PCB layer. Right, let's hide the PCB. Okay, we want. What's going on here? Oh, we're in the PCB layer, that's why. Let's come out of there. Let's grab that. And move it, copy it, and move it over 40 mil. Something didn't quite work out. Oh, it did. It's alright. Right, so we've got that. So we need to get both of them now. But we don't want that, or hang on, we want them, but not that. Right, okay, and we need to cut it. Cut it, and we need to go into this and paste it in place. And we need to bring them out to the front. Okay, put the PCB back. Right, let's have a look. Oh, look at that. We got some nice cutouts. And don't forget, once this is all lined up, which it is, we can, if the PCB spacer gets to be a different size, I'll just grab it and move it up by the difference of the amount. Right, okay, so we've got that. So we ought to, suppose we ought to make what time we got? Closing up to 3 hours. I think this is going to be about it for today. Let's put it back together. We've made a bit of progress. Let's save it. Let's put it all back together now. Okay, oh, yeah. So, I'm getting there slowly, so which is going to be our next thumbnail for second in the series. Don't know, do we look at that bit? That doesn't look good from that angle. It's a pity we haven't got the pins, isn't it? I think we need the pins. We're going to need the pins. Doesn't look right without the pins. Let's grab one of these and I could make the pins part of this, I suppose. Right, pins. Let's have a look at front ways on. Parallel projection. Right, so we've got that. Pins. Let's have a quick look at the pins. We've got one right in the middle. Should be able to create this quickly, the pins. So, what sort of spacing we've got? So between there and there, what have we got? 6.5 mil. We've got 3 mil in the middle. So if we say 3 mil, 3 mil. Can't be, can it? Can't be that much. No. Let's measure one. Oh, I know what we've done. We're actually a bit thick here. We're a bit thick, so we've got 0.75. That's our distance, 8 mil. What have we actually got here? We've actually got a bit more than 8 mil. We've got, yeah, 9 mil. So we're a bit out here. A little bit out, so how do we put that right? Let's just have a look at the width. Total width. Top is 17.5. 17.5 we're looking like from there to there. So we've got 18. Okay, so it doesn't matter. So we've got 18 and we've got 8 when it should be 9. Should be 9. So what do we do? So what do we do? It's only aesthetics. Let's ignore it and just put some lines in. So if we go half of that is there, we go half again. So that's got. So we've got 6.5. So if we go 3.25, and then we go 3.25, 1.675, 1.675. No, that's not right. 1.775. No. 1.725. No. 1.675. No. 1.650. 1.6, that's close enough. 1.650. Okay, and we want a hole in the middle. There, and it needs to be a small pin. 0.75. Oh no. 0.2. 0.3. Radius is too small. So it won't let us do one that small. 1 mil. How do you do a dot? It's a problem with working with a scale. I want to work to scale. They say you're supposed to make it large, then reduce it at the end, but I don't do that. I directly use it for the G code. Right, so I could make it that size, whatever that is. Well, let's just make it that size. We need to go from there. Oh, I don't know. Alright, let's get that and move it over. Yeah. 3 mil. Move it over. 3 mil. Okay. Right. Oh, it's snapping to. Right, we need to change the snapping. If I can find that again. I forgot where I found it now. Is it model info? Yeah. The snapping needs to be 0.5. So should be able to grab that now. So grab that, copy it, put it there. And grab again. Right, okay. Right, compromised a bit. Let's, oh. Can I do that? onto the face. Yeah. Right, so I've got that. Oops, what's happened? Right, that's okay. Am I going to do each one, or am I going to make it up? I'll do each one, I think. Right, so it won't let me do it. I have to do each one. Lost it now, lost the concentration. About 3 hours in and it's difficult to keep your concentration. I can't do it from that angle, so I'll go from this one. Last one. Right, are they okay? Yeah, they're okay. Right. At least I got this ready to do more way one. Right, that's a little bit. Yes, it's only for a placeholder, so we're not milling this out. We're putting them in. We're milling the hole out. So yeah. Right, okay. Close enough. Looks all right. Okay, so that's 3 hours and 9 minutes. What time we got now? 22:10 UK time. That's going to be about it for now. So let's get. So what we've done. Let's give it a bit of an overview of what we've done today. So we've done today. Sized up our PCB. Put our holes in roughly the accurate place. I suppose we could cut pillars made to put it in there. Sort them out. There's your holes, so we've got to create fixing holes in the base to go with it, to mill out, so we know where to screw our standoffs. I've got to do a back plate, so basically lots to do. So what have we done today? We've done the board, we've done all the holes, we've made 2 D connectors and put them in. 1 9-pin Ds, yeah, there's 9 pins. Next to do is the keyboard connector. Keyboard connector next. And back plate with all the extra connectors on here. Phonos, you name it. Okay, so that is gonna be about it for today. Can't see the connectors I've just put on, so let's try to see them at least. See them, but see, yeah, sort of like that. Let's just see. Need to see that sort of thing. Oh, I don't know. that'll do. Okay. Yeah, and we've modified them a little bit. Yeah, so from the side you can see the panel, but from the front you get to see its joint, which is what we might have to do is, I think I've made this 0.6 mil deeper and 6 mil higher than a normal case. So what we might have to do, which has in turn made this area here taller than it would have been, and possibly on a real one, that distance there, let's have a look what that distance there is. 10 point, what is it, 10.6. What's it on a real one? It's a bit more than that. It's a bit higher on a real one, but yeah, it's a bit higher. So yeah, we've got some juggling to do, but anyway, we've got lots more to do. The old idea is to get it in place, and then you can adjust as you need to. So there's plenty to do. Right, I've lost my nice little, that'll do. Right. Anyway, that is going to be it for today. Thanks for watching, and we'll carry on another day, probably tomorrow. I'll try and schedule it up on so people can follow along, give some ideas. But basically what I want to do is create an existing, same one we've got there. So the same, recreate this one, but in something we can make from 6 mil polycarbonate. Alright, so anyway, that's going to be it for today. Oh, I didn't give you any sounds. No beeps or sounds today. That's a shame. Let's give you a few now. Right, let's give a... Yeah, we've missed out on that. Here we go.
Only by computer could they be calculated and for the first time pictorially described.
We got a bit of Daisy.
Daisy, Daisy, give me your answer to the Ford, the carriage, but you look sweet upon the seat of a bicycle built for two.
The art of computer graphics is only in its infancy.
To be or not to be? That is the question.
Thanks for watching, and let's give you an outro. Bye for now. See you on the next one.